Hello everyone, thanks for attending this virtual lab tour. My name is Siu Lee. I'm a graduate student in the Health Sciences and Technology program at MIT. I work under the supervision of Professor Brett Boma and Professor Martin Villiger in the Wellman Center for Photomedicine at Massachusetts General Hospital. Our lab works primarily on optical coherence tomography, including both the technical development and also clinical translation. Furthermore, we work also on other optical imaging modalities such as optical endoscopy and optical microscopy. Today, I'm happy to give you a small tour of what our lab looks inside. So let's go check in and take a look. Okay, so here we are. This is our main Optical Lab. We have several OCT systems in these transportable carts with polarization sensitivity for depolarization, birefringence, or optic axis imaging for various minimally invasive biomedical applications such as dermatology, GI tract imaging, or ophthalmology in collaboration with physicians in Mass General Hospital. And we also have spinning catheter-based endoscope here like this, with the tip looks like that over there, which rotates along the axial directions. And within a one-time pullback, we can create a 3D volumetric imaging of the lumen structure. With the OCT-based endoscope, we can do intravascular imaging such as coronary artery plate classifications based on birefringence depolarization and could achieve more accurate diagnosis. We also work closely with cardiologists for extensive clinical studies. Our lab works with many fiber optics, so we have many fiber spool, fiber scope, and fiber splicing tools, and we do many of the electronic assembling by ourselves. So there are soldering equipments, electronics components, and we also have a chemical bench for sample preparation such as cells, tissues, polystyrene beads, and also other scattering materials. We have people working on fiber laser based on Raman effect inside the single mode fiber. And we also have people using OCT systems to visualize the 3D anatomy of the neural structure inside the mouse brain based on the scattering contrast. Using gold nanorods as contrast agents, we can do multifunctional tissue imaging based on depolarization and birefringence. Recently, we have developed a new OCT technique called circular ranging, which can extend the sensing depth range of the OCT systems, which may be useful in the surgical conditions. On this table here, we have people doing OCT system miniaturization into a portable suitcase, investigating new contrast agents and automated signal processing technique. On the other side of the table over there, we have people building optical attenuation model using OCT systems, and this is for a more quantitative imaging analysis in the clinical settings. Furthermore, OCT systems are a great tool for ophthalmology such as cornea and retinal imaging for pathological diagnosis. And using the computational methods, we're able to do dynamic flow analysis with the OCT signals. Okay, so here we are. This is my own optic table. Interestingly, I'm the only person who doesn't work with OCT system in our lab. My research interest is in imaging through multimode fiber for the endoscopic applications because of the ultra-thin footprint and also the high data transmission throughput through this multimode fiber. Basically, my table is divided into two systems. And this one over here is using multimode fiber, the modes, the spatial temporal modes of the fiber for axial reflectivity encoding within the sample. This is what we call the random sensing matrix through multimode fiber. So this is for axial reflectivity encoding. And the system over here is for lateral imaging or volumetric reconstruction through the multimode fiber. Basically, using the Galvo scanner over here and also the camera over there to calibrate the multimode fiber or measuring the transmission matrix of the multimode fiber. After the calibration phase, we use the knowledge of the transmission matrix to do the image reconstruction. Okay, that's it. I hope you enjoy today's virtual lab tour, and please Google Center for Biomedical OCT Research. That's our official website, and I'll be happy to take any question you might have. Thank you very much.